Hi everyone, welcome to our video on finding an application maximum or minimum. So when it's an application, so like a word problem like down below, we pretty much do the same thing that we did on these just random function problems from a previous video, but often it's a little shorter. So we just have to make sure we still understand the vocabulary. So here's our kind of profit, revenue, and cost types of equations. And then afterwards, it's still kind of our similar steps to what we did on these. All right, so let's break these down. So in this example 4, it says Betty's Cakes finds that their weekly cost function is C of Q equals 120 plus 13Q, where Q is the number of cakes made. Through research, Betty found her price should be P equals 85 minus 3Q dollars per cake. Find the number of cakes that produces maximum profit, and then find the maximum profit. All right, so what do we see here? We see maximum profit. We want to find the number of cakes, so I'm just underlining maximum. So whenever you see the word maximum or minimum, it's telling you get the derivative. So what we want to do is get our derivative and set it equal to 0 eventually. Okay, so that's kind of our main goal for these scenarios. All right, well, with this, we need to still be able to break down and find out what we can use to get to this step. And they talk about profit, and they gave us cost, and they gave us a price. Well, that means we need to use the information above to eventually set up something here that can give us the profit function. So in this, we want to set the derivative equal to 0. Well, we want to make sure we're setting the right function. Eventually, we need to set our profit function equal to 0. So that's what we want to do here. Okay, and they use Q. Often they'll use X. So X and Q are kind of interchangeable, but let's stick with Q. So using this information, I know my profit function is equal to my revenue function minus the cost function. Okay, so we have our revenue minus cost, and then, well, they told us the cost function, so we can put that in at any time. Okay, so that will go right there. They didn't tell us the revenue, but we have a way to get the revenue. So we're going to use this equation here where we know the revenue is equal to our price times the quantity. Well, our price is in terms of a quantity, so we will put that in for our price right here. So that way we'll get R of Q equals 85 minus 3Q times Q. And then here we could distribute, so we have R of Q equals 85Q minus 3Q squared. And that's what we can put here. Okay, so our real first step in this problem was just to get the profit function, but now we have it, so let's go ahead and write it. I'm going to write it a little lower so I have plenty of room. So P of Q equals, let me use my colors still, so R of Q we're saying is 85Q minus 3Q squared. And then we have minus our cost function that they just gave us in the problem, 120 plus 13Q. All right, so we have everything ready. And then now let's start to simplify our profit function. So I'd want to distribute. So our profit function is equal to 85Q minus 3Q squared minus 120 minus 13Q. And then let's rearrange it and combine our like terms. So let's go ahead and put the negative 3Q squared first. And then we have an 85Q minus 13Q. So that's 72. So plus 72Q. And then minus 120. Okay, so there's our profit function. Now that we have our profit function, since we need to maximize it, we'll find its derivative. Okay, so let's get the derivative now. So from here to here is our derivative. And we'll have P prime of Q is equal to negative 6Q plus 72. All right, so we have our derivative function. And now that we have our derivative, we can set this equal to 0. So now we're setting our derivative equal to 0. And then we're going to solve for Q. So I just have to add the Q over. So we have 6Q is 72. And then if we divide by 6, we're going to get Q is 12. Okay, so that is the quantity that should maximize our profit. So it should be it. Okay, and then we could really verify. So that's what our difference is here between these problems and this word problem. So on these problems, we made a number line, and then we started finding where the function increased and where the function decreased. Well, with these problems, there really shouldn't be any tricks up their sleeve. If we found this value, this should be the one that maximizes it. To really check, though, we can get our number line. Okay, so here's 12, so that's my Q value. And then here would be my profit derivative, and then my profit function. And then we would usually plug in test value, so anything bigger in 12 into our profit function. Let's go ahead and cloud that. So if I plug anything bigger than 12, P prime of 20, let's say, so that's bigger than 12. If we plug that in, we can simplify. Negative 6 times 20 is negative 120 plus 72. And all we care about is showing that this is negative. And then if I plug in anything less than 12 into our derivative, so P prime of 0, well, plugging 0 in gives us 72, which is positive, like that. So then it shows that it's verified. It was increasing, and then it does decrease. So it looks like we should have a relative max here, which is the maximum that they are talking about in this problem. Okay, so we do have the maximum profit at Q equals 12. Okay, and then what we need to do for our final step is we'll plug in, let's find max profit, which is to plug that value in to our original profit function. Okay, so our original profit function is right here. I'm just going to highlight the P of Q, and we're going to plug that in. Let me rewrite. So here is P of Q equals the negative 3Q squared plus 72Q minus 120. And then now we'll plug in 12. So we have P of 12 equals negative 3 times 12 squared plus 72 times 12 minus 120. Okay, and then now let's simplify all of this. At this point, we could use our calculator to help us if you don't want to do it anymore. I'm just going to go to the scientific one so that I can just type it in real quick. And let me see it. There it is. Okay, so we have negative 3 parenthesis 12 squared plus 72 times 12 minus 120. And we get 312. Okay, so it looks like our profit is 312. So P of 12 is 312. It's probably in dollars or whatever they said it was. Let's see. Dollars, yep. Okay, so that's it. So their maximum profit is $312. So max profit is $312 when they sell 12 cakes. When I'm going to write as Q equals 12. It was cakes, right? I'm not making that up. Number of cakes, yep. So when Q equals 12 cakes are sold. Okay, so that's our maximum profit. So for whatever reason, if they sell more than 12, they lose money. So who knows why? Maybe it just cost a little, maybe they get sloppy and they lose ingredients. I don't know. Okay, but something happens there where selling 12 cakes is the ideal scenario for this Betty Cakes. Okay, so that's one example. Let's go ahead and do our other example in this video of a business type problem. And still, most of the time, it's using these in some way. Let's break this down. All right, so in this example, it says it cost Bill C of Q equals this function, dollars to produce Q widgets. So they love using widgets in economics, so I'm just using it too, so Q widgets. Find the number of widgets Bill should produce to minimize average cost per unit. Okay, so we need to minimize average cost. So our average cost function is usually written as C with that bar over it. And so to minimize average cost, what we need to do is find the derivative of our average cost and set it equal to 0. Okay, so that's what we need. And I used X, so I guess they used Q here, so I'm just going to change that to Q. There we go. Okay, so that's our average cost function. Here's our derivative of the average cost that we need to set equal to 0, because again, we see minimize is the word, or maximize. Notice it's the same process. If it was when it was maximize, I still needed the derivative and needed to set it equal to 0, so it works the same way. All right, so let's do this. All right, so I need this. So first step is let's get the average cost. So the average cost is equal to, so we use that notation. And what it is taking your cost function and dividing it by your quantity. Okay, and so our cost function is this 0.04q cubed plus 16q plus 1,960. And be careful with Q. I usually try to make it extra curly so I don't confuse it with 9. Okay, so that's what that is divided by Q. Now at this point, you could use the quotient rule to get your derivative. However, because this is a monomial down below, so single term, what I'm going to do is divide each part of the numerator by this monomial. So we have our average cost is 0.04q cubed over q plus 16q over q plus 1,960 over q. And then that way I can simplify each of those. So our average cost function is 0.04q squared plus 16. And then this I'm going to change into the negative exponent, so plus 1,960q to the negative 1. All right, so there's our average cost. And then now I want to find the derivative. So the derivative, c bar prime of q, is use the power rule on this first one. So it looks like that would be 0.08q. The derivative of a constant is 0, so then I can move on. The power rule on the third term gives me minus 1,960. Minus 1 from the power would be q to the negative 2. All right, so now that I have the derivative, well, if I have a negative power, in these scenarios, I usually don't like seeing it. So instead, I'm going to change it back into a positive power. So I have 0.08q minus 1,960 over q squared. And then I usually like just getting a common denominator. So this needs to get a q squared underneath, which means I need to multiply it by q squared as well. Okay, so a few things there in one step. So that way I have a single fraction bar. And then in my numerator, I still have the 0.08q, it would be cubed, minus 1,960. Okay, so this is our derivative of the average cost. So let's go ahead, I'm going to cloud it. It's nice to have. All right, and now that I have this average cost, well, usually our steps to find the, so we called them the critical numbers, was to set the numerator equal to 0. So the critical numbers, let's set our numerator equal to 0. So we've got 0.08q cubed minus 1,960 equal to 0. And let's set our denominator equal to 0. Okay, so the numerator and denominator are each set equal to 0. And then we'll solve each of these. Well, this first one, I would want to add the 1,960 over. So we have 0.08q cubed equals 1,960. And then we'll divide by that 0.08. Okay, so that's going to be too tough for me to do without scratch work. I'm going to use our calculator friend again. Okay, so 1,960 divided by 0.08, and we get 24,500. Okay, so we've got 24,500. And then to get rid of a cube, I would cube root. So cube root both sides, With a cube root, I don't need plus minus. A negative wouldn't make sense anyway, even if we were to put a negative in it. So I don't want that. So cube root, though, doesn't need it. And we have our q is equal to, okay, so that I need a calculator as well for. Okay, so I want to do this. So the cube root, you could type it in with this. Let's see. So let me hit enter to get a new screen. So this, and then 3, and then let's click 24500. All right, and we get this value 29.04. Okay, so we have 29.04, and it would be widgets is our critical number. Okay, so let's box that up. Where q squared is equal to 0, well, square rooting both of those would give us q equals 0. This would be considered a critical number. I'm going to cloud it, but it really wouldn't make sense. Obviously, that would minimize cost if your quantity is 0. We're assuming, though, that he will make stuff. Okay, so 0 would always minimize something like this in this application, but again, we're assuming he's actually going to make these widgets so that eventually he could sell them. All right, so anyway, so 0 is not important to us. Instead, I just want to I'll make a number line. So we usually dealt with our number line. And let's put that 29.04 there just to verify. So it should go like this. It should be lower and then upper, so it should decrease and then increase because this should be a minimum. Okay, and again, they really shouldn't have any tricks up their sleeve. You can assume this is the value that should give us the minimum, and then eventually we would have to kind of round, either round to the nearest widget or round up to the closest widget. All right, so anyway, so this is what our average cost should be doing. And then, but we'll double check, and then I'm just going to put 0 down over here just to show I don't really care left of 0. All right, so these are our Qs, and then I just want to plug anything bigger than 29.04 into our average cost derivative there. So if I plug in anything bigger, I'm going to plug in 100. All I want to do is check the sign. Well, it will turn out to be positive. So if you cube 100 and times it by 0.08 and then subtract, it should be a positive. So I'm going to skip some of that work. So that should be a positive when it gets all simplified. And then 100 squared down below would be positive. So 2 positives divided is positive. And then if I plug in anything left of 29.04, again, probably bigger than 0 because we wouldn't want to make 0 widgets or less. So let's go ahead and just use 1. So C bar prime of 1. If I plug 1 in, the top would be negative because 0.08 minus 1,960 is negative. Divided by 1 squared is going to be positive. So a negative divided by a positive is negative. Okay, and like I said, that's what should happen. They're not going to trick you. So this should be a relative minimum because that's the one quantity we found as a critical number that makes sense. Okay, so sometimes like the Q equals 0 really doesn't make sense for this scenario. Okay, so that's it. So it said find the number of widgets Bill should produce to minimize average cost per unit. So if they said no rounding, or at least keep a decimal, we would do this. If we round it, round nearest to the nearest value, then this one should be rounded down, 29. If they say rounded up, because sometimes in business they just round it up to the nearest whole number, or the round up to the next whole number, then you would say 30. Okay, so these are all the different answers depending on how they word it. Okay, so if they say just give us a round to 2 decimals, this one. If they say round it to the nearest whole number, that's this one. If they say round up to the next whole number, then that's that one, 30. Okay, so that's that. And if they said, hey, what is the average cost? Well, then you could plug it in. So if they said, what is the average cost? Average cost, we could plug it in. C bar of the 29.04, or again, whichever ones they want you to do. And that would be using that would be using our average cost function, that one right there, to find the value. Okay, so I'm not going to do that because they didn't ask for it, but just that's what we could do. Just like in the previous one they did want it, so we did plug it in. But notice on this one, they just said the number of widgets. Okay, so I'm going to stop it right there. All right, so that's that. So there's our business ones, or at least 2 examples with kind of the main cases that we usually see. If it's not one of the main cases, well, take these same strategies. You still got it. All right, so it's still very similar to these types of problems or these types of problems. All right, so I believe in you. You got this. If you have questions, though, please let me know. Otherwise, thanks for watching, and I'll see you next time.